right, let's next look at example 6. We are trying to find f double prime. We're finding the second derivative, which means we take the derivative and then we take it again. All right, so f prime of x is the limit as h approaches 0 of f of x plus h, so 2x plus h squared minus 3x plus h plus 1 minus f of x, 2x squared minus 3x plus 1 divided by h. Okay, so we'll have a 2x squared, which will cancel out, a 4hx plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1, all divided by h. Now, several terms cancel. 2x squared, the 3x and the negative 3x, the 1 and the 1. Factoring an h out. Factoring an h out, we get 4x plus 2h minus 3. Now, that cancels. And as h goes to 0, that means this is going to be 4x minus 3. All right, so that is f prime of x. All right, so to find f double prime of x, we're going to start with f prime of x, that function, and do the same idea. So the limit as h goes to 0 of f of x plus h, that is 4x plus h minus 3 minus 4x minus 3 over h. Okay, well, that'll be a 4x and a 4x. Those cancel out. So we get a 4h, and actually the 3 cancels out, 4h over h, and so our limit is going to be, once those cancel out, 4. So f prime of x equals 4. Now that should make some sense, because once we have the function 4x minus 3, the slope of that function is 4 everywhere because it's a linear function. All right. Let's move on to another. Find f double prime of x squared. Now, we actually found f prime previously. It was at the very beginning of this, and that function was 2x. So let's just go ahead and use that. So f double prime, okay, f double prime is the limit as h approaches 0 of f of x plus h, so 2x plus h minus f of x over h. All right, the 2x's cancel out, so we get a 2h over h, and that slope will be 2. So f double prime of x equals 2. Now, it's worth noting that there are lots of ways to write this. So, for instance, f prime of x is the same as dy dx. So, f double prime of x is d squared y over dx squared. That indicates the second derivative. And there are actually several other ways to denote derivatives in physics. There's one particular notation with dots, but we're not going to go into those. But be aware that is what's going on if you see a dy dx. That's what we're looking at. All right, number 8. The position of a particle along a coordinate axis at time t is given by s of t equals 3t squared minus 4t plus 1. Find the function that describes its acceleration at time t. Okay, well, acceleration, if we think of s of t being position, because it is, then the derivative of that is velocity, and the derivative of that is acceleration. So this is s prime of t, which makes this s double prime of t. So really we're being asked to find the second derivative of the function we are given there. That's what it comes down to. All right, so the limit as h goes to 0, this is s prime of t, of s of t plus h, so that's t plus h squared minus 4t plus h plus 1 minus s of t, 3t squared minus 4t plus 1, all divided by h. Multiplying that out, that is a 3t squared, which will cancel out there, a 6th, okay, that'd be 2 of those, so 6, plus 3h squared minus 4t minus 4h plus 1 minus 3t squared plus 4t minus 1, all divided by h. All right, several terms cancel out as they should. 3t squared, the 4t term, the plus 1 minus 1, and we can go ahead and factor out an h. 6t plus 3h minus 4, or h. So that limit, as we evaluate h going to 0 and cancel those two h's, we get 6t minus 4. That is our velocity function. All right, now we can sort of use a shortcut here because this function is linear, so the acceleration is going to be 6 because that's the slope of that line. Now, of course, we can go ahead and say a prime, let's go ahead and write this, a of t equals s double prime of t equals the limit as h goes to 0 of 6t plus h minus 4 minus 6t minus 4 over h. Keep this in mind, this ought to be our answer. All right, well, our 6t's cancel out as do our 4's, so we get a 6h over h, which is a limit of 6.